Okay, I don't know if John can hear me, but I just want a couple more folks to join us, and then we can begin. So what I started last week was a very big, should I say, high level overview of what Python has to offer. And I didn't go into so much detail because, it's a beginner class. And so my goal in the first presentation was basically to give a very high level overview to show you what you could do with Python and how to even go about it. So, our first presentation, I just did a quick look at the setup for those that haven't installed it. I also considered what IDEs that you might look at. And so for someone like you, Alexander, that is looking at doing data science or data analytics with Python, you already mentioned that you're familiar with Jupyter. So yes, means that that'll be your IDE of choice to work with, and it's cool. And for the rest that might not be doing data analytics, then you have also other IDEs that you might want to consider. But in the end, there are so many options that it doesn't really matter. You choose the one that you are very comfortable with, and then you go. All right. So once you are set up, usually what comes next is to just cover the basics of what Python has to cover. And in most programming languages, you start with understanding how data is, represented in the computer. And so we'll talk briefly about variables. And then also, variables, you look at the different types of data and, values, and then their types. And so that's the thing that we covered last time. And then I did a quick look at decision making in Python. So I'm going to play around. I'll just do a quick review before we go, so you don't miss out completely. And then we will today look at it into a little more detail. I'm going to slow down much more than I did last time, even though it was something that I did in a slow pace. I gave such a high level overview that you couldn't do too much with the information. It's just to orient you. Okay, so I thought that would be good for you to have that, kind of background. So that's what we're going to do today. So let's hold on, and we're going to start very soon. Okay. So for the other participant, I see Ifyo Lua here. What about you? What are you learning Python for? You just joined us.
I'm learning it to build applications, to program applications.
Oh, and what's your experience with that so far?
Well, I just started it. I only had um ideas on C++ for now.
Okay, so you can already, I don't know, to what extent can you program in C++? I did C++ so many years ago. I don't even remember what it is, but I haven't used it in school. Yeah.
C++ is more of the use of Visual Studio. I'm using Visual Studio for C++. So it's close to Python programming.
Yes. Okay. All right. Then I can already see that your path then in Python would be to go the Django way. Do you know about Django?
No, I don't.
Okay, so your future looks to me like you're going to be using the Python framework that is used for developing web applications. Okay, so if you would just do a quick Google search, let me share my screen and jump into the browser while we have this quick chat. I can share a few things before we jump into the main business for the day. So you can already see my screen, right?
Yes.
Great. So if you're here, you can just search for Django.
Okay.
Yes, and then this is it. As you can see, it says Django makes it easier to build better web app more quickly with less code. So I've used it for, in fact, my current website is built with Django. Okay, and
Oh,
if you know all the basics, okay, which I'm going to cover today, up to the intermediate level, you should be able to start looking at Django. All right, let me go to the overview, and then as you get into the more advanced uses, you would definitely want to get a good understanding of classes. You know, someone asked me about classes the last time, and I'm like, it's not something that you want to just jump into right away. But again, as an application, you know, a framework as big as Django would definitely implement, make use of classes. Okay, so at least if you look at this, you would see. So the whole setup about Django is basically summarized here, you know, and if you already know something about web development, okay, you would appreciate what Django gives you for free. Okay, this portion is how you define your databases. This portion is how you write the logic that handles the web requests. This portion allows you to create web templates, you know, for displaying the pages that you write, etc. Okay, so you check it out and you can then target your learning towards it. There is also a website that caters specifically to people that want to do full stack web development in Python. It's also available on the web. So that's something for you to consider.
okay. Thank you very much.
Great, you're welcome. Okay, so I think we can begin and continue from where we stopped last time. So as I was explaining on the first session, we looked at the very basics. Okay, and as I explained, my goal is to orient you on, you know, how to begin, because most of this journey is going to be on your own, right? I'm just going to help you lay the foundations for you, and you have to learn a lot of the things for you. And the way I learn, I like to get a high level overview of things. So the reason that I shared that resource. And just a bit about me for those of you who were not here the last time, right? So if you wanted to, those of you that are interested in data science, I might be able to answer some questions for you as time goes on. And for people like Ifeoluwa, I just answered a quick question for you on Python web development also. So when the time is right, I might be able to provide some information for you as we go. But for today, it's just an extension of what I began to do last week when I covered the basic of Python code. See that it's a language, and a language has a vocabulary. Okay, it has also the grammar and a certain formatting of the code. So I talked about some keywords that are reserved in Python. I also talked about how to stitch those words together in the correct order to make sense. And you know how Python formats its code. So basically in Python, we use indentation to format code, right? And you have to consistently format code in a certain order. I'll show you in the IDE, okay? Then as part of, this is a practice that is, in fact, there is a whole standard on how to write your code in a way that other people are going to, you know, benefit when they read the code. And sometimes too, you can write your own code and you come back to it and then you would have forgotten what you wrote. So commenting is a feature that all programming languages provide for, so that you can identify or highlight code that would not be executed. Okay, and it's just for you to, run your program successfully. And so basically that was it. And then I went further and explored variables in some keywords. We also looked at these. This is Python statements. We looked at some operators, and then we looked at how to write a few expressions in Python. I'm just going to quickly go over that, and then we will jump into what our business for is today. I'm just going to go a little more detailed into this aspect. We would have a few practice questions which I'll throw to you, and then we will solve them together. All right, so let me quickly jump into the IDE, and then we can begin. Okay, so my IDE is coming. Great, so here we are in my favorite IDE that I like to use for this purpose. Okay, so like I was looking at the last time, as I explained to you, I'm just going to restart my Python kernel here. And just quickly go over, I talked about the various data types that you have in Python, all right? And you can, Python is very flexible. When you create your variables, you just create them on the fly. Okay, so you can just do something like that, and then voila, your variable is created. You can create another one like that, and then you have another data type is created. If you wanted to see what type of variable, what is the data type of the variable, there is this function here, type, that you can use to inspect the type of variable, and then it tells you that it's an integer. You can do the same thing for y, and then it will tell you that it's a floating point number. Okay, so for the decimals, and then you can do the same for text data, all right, which is denoted using the string, the double quotes, either this one or that one. And then so you can see also the type of this message here, that it is of type string, right? And typically these are the most common data types that you'll be using. Later on, when we go down, in fact, I call these the atomic data types, because then you can have data structures, which we'll talk about later on, that can be collections of these basic types, right? And so with this, you can begin your work in Python, right? And then when it comes to the Python naming conventions also, for example, you cannot create a variable that begins with, say, a number, all right? And say, this is my variable. Why not? Okay, so let's say I created a string variable like this, and then I get the warning that it's invalid syntax. Okay, so your variable names can be a composite of, it can take so many forms, but one of the forms that it cannot take is for it to begin with a number. So you can do things like, and these are all valid names. Okay, so so this is basically from last time. I can clean it up. That's just what I've explained for you here. So if you look at a couple of valid names that we have, can be, you can have something like this. This is a valid name. Okay, it's equal to some name, all right? Or you can have something like, if you wanted to do all lowercase, okay, I mean, that would also work, but you can see that perhaps it's not that easy to read. Okay, so you might use an underscore to separate the name. Okay, and then also give it some name like that, okay, which works nicely. Or you can use another format like this, which you would see. It doesn't really matter. I mean, but there are, later on, as you master this, you'd realize that there are conventions that you can follow. Okay, so these are some of the practices, and all these are acceptable. You could also create a name that begins with an underscore. Okay, some variable. Okay, and then we give it some value. Okay, so the underscore is a valid character that you can use to, you know, it can begin, or it can be anywhere. It can be at the end, and literal, you will see how Python itself uses underscores a lot in its naming convention. In fact, if you use this function, so I'm showing you this function here, okay, you would realize in Python's namespace that it uses the underscore a lot in its own namespace. And I won't talk too much about this, but these are some of the names that are being currently loaded into Python when we started the console. So this is a special word here. If you were curious and you wanted to see what's in it, you can use this function. So this function here is an inspection function built into Python, and you can take a look at what this function does. So it returns the names in the current scope. So for you that are beginning, a lot of the times you want to see what are the names available presently. It will show you a list of names being either properties or functions that you can use. So I'm giving you this function. You should keep it in mind all the time. It can help you know what's up. And you see the way I used it just by typing dir like that, automatically listed for me some variables that are present in the current environment, right? The namespace. So you can do the same and see what you get. Okay. And if there are several ways to use it, you can also use it around, say, you see the variables that we created is you can do this, and you will see names that are associated with this. Now, these will make sense to you later down the line. Okay, Python variables that we created are actually Python objects. Okay, so in Python, everything is an object with several properties. Okay, and then also methods that you can use. So these are all the names that are currently associated with this int object. Okay, it's an integer. Does it make sense what I'm talking about? So for example, if you wanted to explore what this property is here that has been listed, you can further go down and take a look at it, okay, using the dot notation, which we will come to later on. But in respect of names, these were a few additions that I wanted to mention, you know, addition to what we talked about last week. Okay, so any questions? If you want to ask a question as we go on, just type into the chat. I'll be monitoring, and then I'll give you some feedback. But again, I want this to be interactive, so don't let me talk too much. All right, just interrupt me, ask a question, raise your hand, and let me see if what I'm talking about makes sense for you. All right. So the additional thing that I would add to this is that you cannot, if your variable name is a composite of some two words, okay, you cannot use a space. It doesn't work. You cannot use a space in between and say this is my variable. Okay, this doesn't work unless you're doing something like this, which means something else. Okay, but this one is a meaningful syntax. Okay, and can someone guess what this is actually doing?
Assigning variables to integers.
Oh, but I should, yes, but can you add a little more flesh to what you've said? So what would be the value of this first one
23,
and this one?
34.
Okay, all right. So as I think I typed wrongly, but you can see what is happening. So you can do multiple assignments on one line like that, and that should work. So if you saw something like this, it shouldn't surprise you. It's valid and it works. Okay, so those are a few things that I can talk about right now that comes to mind when it comes to the variables. And with this, you should be okay. Now remember also that Python is very flexible in the way it allows you to create variables, right? So that you have to be careful. Otherwise, you might change the value of a variable at a point and you might not even realize that you've done that. So look at something like if you have, let me still use X is very simple. Okay, so X here is a number. All right, let's say 10. If you are not naming your variables properly, okay, or you decided, you could at any point in time change the value of X into this is the new value of X, and it works, right? So what is the value of X presently? It's a string. See, so what you started with being 10 is no longer a 10, okay? It is now a string that is showing. So you should just realize that Python on the fly allows you to set the values of your variable, okay? And it will automatically handle the conversion. Now it is a string, but you began with a number, an integer. Okay, so you should also know that this is possible. And then one more thing on variables and data types is that there is what we call type conversion. Okay, where you can change from one data type to the other if the conversion is a valid operation. Okay, so what kind of data type conversion might you be interested in doing? So you may be able to, for example, change an integer, okay, to say a floating point number, or the reverse. This is something that you could do. It's a valid operation. You can also do the reverse. What about, can you also change a string to say an integer or a float? Can you do that? Anybody?
I don't think it's possible because strings are made of alphabets, while integers are numbers.
Okay, that's an answer, but is that an absolutely truthful answer? Are strings only made of alphabets? So yeah, this is a question that I would love you to answer. Are strings always alphabets? So look at this. So look at this number here. I'm clearing my screen so you can see. What is the type of this variable that I've created, this number? What is the type? What is the data type?
Integer.
Is it an integer? Okay, who agrees that it's an integer?
I agree, it's an integer. Yes, I agree.
You also think it's an integer?
Yes.
Okay, all right. So we have 2 votes. Any other person with a different answer? Okay, let me go ahead and we can do the inspection. So I'm sorry to disappoint you, but it's not an integer. It's a string. Does it make sense why it's a string?
The inverted commas.
Yeah, comma.
Yes. Yes. So you should know that your inputs, your data can be alphanumeric. It's always alphanumeric. So string can be alphanumeric. It can be a number, but it may not be of the integer or floating point or the number data types that Python recognizes. Okay, so not every number may be used for computation. And in such a situation, you might be free to leave it as just a string of characters, which may not be used in mathematical operations like that. So this is actually a string. And in programming, there are times that if you have situations like this, or if your program anticipates that you're going to have situations like this, then you have to deliberately take care of it by doing the type conversion. Okay, so even though the numbers here are numeric, the characters are numeric, the data type here is a string, and Python doesn't automatically do the conversion for you. You have to do an implicit conversion. Okay, so here, the type conversion that you need is a string to either integer or floating point number. So for example, how might you do a conversion? You would use the appropriate data type to convert. So as I was telling you, the data types that we already talked about, okay, which I summarized for you, these types here, some of them, we have the int, we have float, okay. We have also, there's a complex data type as well here. Oops, sorry. And then you can also have the string, right, which is, oops, which is also here. And these functions, these are also functions that allow you to do the conversions that you need. Okay, so we can easily use them for the task at hand. All right, so let's engage one of these. So in our case here, if we wanted to just convert to an integer, we can put this number in here, and we are gonna get our integer. Okay, so just so that you can verify what type it is, I'm gonna wrap this function around the whole expression, and we can check the type. So you can see the way I'm nesting this whole thing into type. All right, so you can do that. It doesn't always have to be something like this. You store this into a variable, right? And then you can check the type like that, or you can just do this nested expression and it should work fine. Okay, so yep, or you can just go ahead and do a conversion too. And the reason that I'm bringing this up is if you were to get an input from the user, from the keyboard, right? It may not come in the format that you require. And you have to, you know, go out straight and then prompt or do the necessary conversion in order to be able to use for your computation. Now, if you didn't do this conversion here and you thought it was a number, okay, you might do something like this. Okay, this number, let's say times 3. What do you think the output is going to be?
I think it will be an error.
Would it give you an error? Okay, that's a possible scenario. Anybody else with a different answer?
Yeah, I concur because it said from what you said, if you didn't convert, right? If you
Yeah.
didn't convert, yes, give an error.
Okay, let's see whether we're going to get an error. Is this an error? Who can see what is going on?
Binary.
Is it binary? Okay, it looks
No,
binary
actually,
because of the original number. Now let me change this. I'm going to reassign this number to another value that is obvious. Okay, 1, 2, 5. And then I'm going to run the last computation again. Oh, sorry, I did the wrong thing. I should put it in quotation. Yes, and then I run. Good. So can you see?
Okay, I think you placed the number 3 times.
That's
You
right.
duplicated the number twice, three
3
times.
times. Good. And this is proper according to the way Python works. This is actually, it's not wrong. In a certain context, this operation here is valid and meaningful. And this actually is valid when you are looking at string manipulation. If you are manipulating text data, multiplication has a different meaning. Addition also has a different meaning. And these operations can be done, right? So it's showing you that in some cases, in fact, this might be on your part a logical error, right? Because, or you might call it a semantic error or something, but you're getting an output that is unexpected because you fail to account for something that should be accounted for. And these are things that when you start programming that you should pay attention to, because they can happen a lot of the times. You may write code that runs correctly. It doesn't shout at you and say, hey, there's an error, go and fix it. Okay. And so you, as part of your programming experience, as you grow, you would also begin to learn how to figure out potential errors in your code. But this is a good example that I've given you. Now, let me show you where a situation like this can occur. Okay, so if you want to get input from the user from the keyboard, there is a function in Python that allows you to get data. All right, now this function here, we can learn about it. It says that, so this is the signature. Let me clear the screen so that you can see it clearly. All right. So this is a function. It expects a prompt, which is a text, okay, that you provide. And yeah. Okay, so let's just see. It will just allow you to read from the standard input. Okay, so let's say, for example, we put this function input and we specify the prompt as, say, type a number between 1 and say 10. Okay, so that is the prompt. Can you see? So it will show this prompt and it will be waiting for me to input a number. Okay, So I type it and it returns that number. So you can see now, typically you won't do this. Okay, what you want is to be able to collect the feedback that the user gives you. Okay, so you want to save this in a variable. Okay, so you could do something like this: response is equal to prompt. Okay, and so if I type my number, this time you won't see it on the standard output, right? Because the response that the user gave has been saved in the variable called response. Okay, so if we wanted to get access to it, we can see. And now you can go ahead and do with it what you have to do. But as you can see, it's a string. So you need to do your type conversion before you can actually make any meaningful use of it. All right, so at this point, I have gone over quickly the data types, variables, and then I have added a few things to it, getting inputs from the user. Any questions? Any questions, feedback? Okay, so if there's nothing, then I'm gonna go on and then just move on to the next thing, address a few things for us. Okay, so let me now quickly go on to conditional execution, which I also touched on last time. And so in Python, and in other programming languages, the need to test for conditions and base a certain path of execution on the result of the test is always important. All right, and there are a couple of structures that allow us. The simplest one is the if structure that allows us to do branching. Okay, but usually the way this works is that the expression results in a Boolean value, and based on the truth value of the expression, we get our code to execute in a certain direction. So it means that we need to have some basic understanding of some things here, mostly including Boolean expressions. Okay, so for example, if you type this, what does it mean?
Equal 5 equal 5. That's
What does this mean? What am I trying to do in the language of Python? So I'm trying to do a comparison between this value here and that value. Is 5 equals to 5? So this is the operator that we use for doing comparisons. And there are a couple of other logical operators. You remember the last time I introduced you to the help feature. If you go there, you can quickly search for topics. And there are a couple of operators that, well, this is not the only place, but I'm showing you because this is already built into Python. Okay, so that if the moment you are playing in your IDE, you can also have access to this without getting another book or resource. So that's why I'm bringing it up. All right, so if we search on operators, we can already see. Okay, so there are so many of them here that we talked about. Okay, so you can see comparison operators. And this is the one that I used here. There are a couple of other ones, the less than or equal to, the greater than or equal to. This is a negation of this sign here. Okay, so you can do this or you can do that. So let's put these in action and see how we might use them. Okay, so let me quit from here. So what I did here, 5 equals 5 results in a Boolean value. Okay, and this is a Boolean expression. The output is this value. And usually when we are doing conditionals, we are evaluating expressions that would result in one of these values, either a true or a false. And if you checked if you check the result of this operation, it will tell you that it's a Boolean. Okay. You could also do the next operator that I talked about, the not equal to. Okay, is 5 equal to 5 or not? It's also Boolean, but what is the Boolean value here? And you can check it out that it's false. Okay, so this is the not equal to. There are also things like 3 is greater than 7, and it's false. Okay, so what about the other ones? So these ones, they look very familiar because of mathematics. All right, so all these, this one here, greater than or less than. Okay, and then the inequalities are also greater than or equal. It's also familiar. Less than or equal is also familiar. The only one that we might want to look at carefully is the negation operator. Okay, so not equal to. So if you did something like this, 3 is not equal to 7, what do you expect?
True.
True. This is supposed to be true, right? So good. And then we have another one that is. Okay, so this is there any information that we can gather on this? Okay, so let's check. Let's say is 3 the same as 7? Okay, so if it says false, but then it gives us some warning. Okay, so it means we are actually not properly using this operator the way it's supposed to be used. Let me give you another use case. Let's say 2 is x equal to 2, and then y is equal to 3. Okay, so it's x, y. X is not y. What about if, let's do the same thing again, x is 10, and then y equals x. All right, let's see, this time is x. Oh, I'm reading the English version. Okay, so x is y. And it says it's true. Can you guess why this is true?
Because you've assigned the value of y to x.
Well, yes, I mean, it follows from that, but there's a deeper meaning to why this is the case. Yeah, so actually, the way assignments work in Python, this here looks like they are referring to the same object back behind the scenes. Yeah, they are referring to the same thing in memory. Okay, only different names but pointing to the same memory location. And so things like this, perhaps right now we won't find any real use of it, but it's there, okay? And then the opposite is also there. You can combine this and that, okay? This and then a not, okay? So can you also do something like this? So you can do something like that. It means that, for example, you could do something if not, okay? Can you do this? Or in fact, let me not add if yet. Okay, let's just do this. So you can see the result of how this evaluates to true and then or false, and then this negates it, but we are getting false because this is evaluating to true, and then this will negate the result of this expression here. Okay, so these operators are there for our use. Okay. I've got a comment here, the variable reassignment on line 50. You can unmute your mic and talk. Yeah, so someone has a Kweku, do you want to talk about this? All right, so let me proceed. Okay, great. So basically those are the Boolean expressions, and then the logical, the comparison operators. Okay, then we have some additional operators that I want to talk about. So we've seen the Boolean expressions. We've also looked at the operators, the comparison operators. Okay, so I just talked about the comparison operators. So let me also talk about a few more operators that I've just mentioned them. So one of them, we have AND. Okay, is an operator, or is also another operator. Not is also another operator. So there are these three operators, logical, that you can combine with what we've seen, even with the comparison operators. Okay, so look at something like this. What is the value of X now? Okay, X is 10. What should this evaluate to? This expression here, what should be the output?
True.
Is what?
True.
True. This should evaluate to true. Okay, but then we want to change this condition with another one. Okay, so we want to test whether X is positive and it is also under 20. Okay, so this is when you might use this logical operator and combine these two expressions. So what should be the output here?
True.
It's supposed to be true. So do you think I can do something like this? Yes, I can. All right, so you can see how we can combine use the logical operators. Okay, so what about if I just wanted to say that X can either be positive or it can be under 20. Then I can use the OR operator. Okay, and then we can, what should be the value? It should be true. We just evaluate to true if one of the conditions are true. Okay, so this is how, and it doesn't have to be just one. two operands. Okay, you can combine multiple, you can combine so many conditions together. So you can have this and then you can have that. Okay. See, so you can chain them up as many as you need to use and use them. So these are your operators that you can also use for decision making. All right. So once this is understood, then you can feel confident about going about your conditional execution. So the simplest way, we just jump in straight away. All right. And we do our conditionals. So the way you prompt Python that you want to test for some truth conditions is to bring in your if, and then you construct your logical expression that you want to test for. Okay, so over there we already have some variables in memory. Okay, so if the set condition is true, then you want to evaluate to a certain, give us some output and say that, okay, this is what is the condition. Okay, and just say that x, say positive, right? And that's it. So did we do everything right? Okay, yeah, let me just define some x here. All right, so this is, and that's it. Okay, so this is the simplest case of it. What if, I mean, this is not the only thing, but you need to give a second what can be done when it's not the case. So remember, the fact that you state this doesn't mean that something will happen if x is not if this condition is not met. Okay, as long as x is positive, this thing would execute. But what about if x is not 10? What would happen? Nothing would happen. The way the program works, okay, nothing would happen. So let's change the value of x this time. Okay, and run this line of code here. You see that it's quiet this time because the test condition is not met. And so if you want something to be done when this condition is not met, you need to handle it and plan for it. And that's when we use the else clause. Okay, else, then you can handle that and say that let's say in our simple case here, oh sorry, x is negative. Okay, and so in this instance we have x is negative printed. Okay, so this is the alternative path when the test condition is not met. Now remember, you have to specify this all the time, otherwise this will work unless you are not interested in what happens here. Okay, then you can leave it, but it's good to handle these two branches of the test condition. Okay, so this simple case here is easy. Okay, then you can even change the conditions. So what different conditions can we have? If you have, say, an integer, it can be, we can have three situations, right? It's either x is positive. Okay, so x can be positive, x can be negative. Okay, what else? So what else? These are the two scenarios, right? Or equal to 0 or 0, right? Okay, in the next round of testing, we are going to compare two numbers. Okay, so we have x and y that we want to compare. Now for these two numbers also, we want to check three things. Okay, so again, there is the two inequalities and then there is one equality. Okay, so let me now, I'm going to add y. Okay, so y is let's say 10. Okay, so let's go and do our test. We said that if the first thing is we want to check if let me start from the negative side. It's either x is greater than y, right? In which case we want to write x is less than y. Okay, but what about the two other conditions where x is greater? Okay, so let me write those conditions here, and then you can follow with me. So let me start with the less than. X is less than y. Okay, so let me properly format this. Okay, or we have the case that x is greater than y, or we have the situation that x is equal to y. Okay, so these are the three scenarios which we must handle all. Okay, so quickly, let me handle all the three branches, and we will be good to go. Okay, so now with the chained conditionals, what we are going to do is we're going to add this branch, which we introduce with elif. Now you can see that this is a combination of the alternate branching and another test condition, right? So else if x is greater than y, then we have another branch that we must handle. Okay, so this time we want to say that x is greater than y. Okay, then what about the last condition? We can also, how do we handle the last condition? The last condition is the last one, so we can just leave it at else, right? And say that, give us this message. Okay, so we can say that x is equal
So
y. Okay, so you can see how now you can chain things together. So let's run this. Do we even know the values of x and y now? Okay, let me erase this and run this. What do you think should be the output? Okay, the last branch works. If I swap this out and I make it like this, which branch works? The first branch, right? And so the third branch also works. So this is just another way that you can chain conditions, okay, and make it work. Okay. Any questions?
no, sir.
Okay, great. All right, now you can also do a lot of other combinations of the if. You can now do another version of the if. You can, or let's say nested conditionals. So you can go as far as you need to, keep testing. And so you would see something like, okay, if x is equal to y, let's print x and y are equal, okay? So this is one branch, okay? Else, and maybe someone can help explain, or we can do something like this. Else if x is less than y, then print. So okay, and you can see that we are basically implementing the same thing. Okay, s is less than y, else, okay, then we can print X is greater than Y. Okay, should this also work? So see what we did first time. You can also do a different approach by changing the way you set up your, test cases. Okay, so first one, we check for equality. If they are not equal, then one must be greater than the other. Okay, so you can then check for the less than, and then if this is not, then you know that it has to be the other way. So this is another way of doing your, either you chain it or you can nest. Okay, so and this can take several forms. So you can see that when I work this out also, it should work. Okay, you can do one test after the other. Let's see another example. Like, say we have a sick person, okay? Someone comes into the hospital and we want to check whether the person is infected with say malaria, right? Okay, and we say yes. Okay, but then we also want to check whether this infection has been longer than 2 weeks. Okay, so I don't even know what this means, but I just want to create a scenario for you. Okay, it's longer than 2. Okay, and okay, this is also true. Okay, it could be false. All right, what you are interested in is you want to say that if I don't want to retype the whole thing again, but it tells you that this variable name might be better than a short variable name that you cannot remember what it's doing. Okay, if the person is infected, you can check again to see. You can nest this up again and then do another test. And the reason is, the only reason why you want to check this condition is if this condition is true. Okay, so that's why you might do this nesting. Okay, then give out a message and say, yeah, we can't help you. See, so let's see if this works. Yeah. Okay, so this next nesting here can be done, and you can do it so many levels deep depending on what you want to do. Okay, does it make sense? Okay, then let's do some exercise. I want to give you a few questions, and I hope you are able to write it out. Okay, so the first one, I want us to work together. If somebody can help us, that would be really great. So this is very simple. Can you write a program to check whether a number is positive or negative? If you cannot write and you want me to type it out, maybe you can tell me, but if you can just write it out by yourself and share your answer, that would be great. Anybody wants to help? Oh, are you there, my people?
Yes, sir.
Anybody can help us with a solution? Can you write a simple program to check whether a number is positive or negative? So let's say the number is going to be read from the the input, right? The standard input. Someone is going to type it out from the keyboard. Who can help us, right? Just combine a few ifs here and there and see. Can you give us the program flow? Or you can, if you don't want to type, I can help you type it out and we can see the solution together.
Okay.
So let's do the first one. Okay. Yep. Read out your solution to me and I type it out.
Okay. If x is equals to 10.
Okay, but I want us to read the input, the data from the keyboard. You remember I showed you how to do that? Who remembers? Okay, just to save time, let me help you with that. Okay, so
X is okay. Input.
and you don't always have to type the prompt, but you can just say something like this.
Input.
All right. So what do we do next? Okay, let's go. This is how you know that you know Python, if you can solve a simple problem.
Okay. Let's use 10 as the number.
I mean, you don't have to worry about the value of the number. Okay, once you read it in, see, let me just run it here for you to see. Okay, so if you say we should use 10 as the number, x now has 10. Okay, so you shouldn't worry. I want us to continue with this flow. All right, so Tiago says to do a type conversion. Okay, so if you want to see the chat here, all right, so we can do a type conversion. So I'm gonna type conversion to what we would have to convert the type to integer. Okay, so I can wrap it around it like this.
Yeah, I think we would have to convert the type to an integer. Yeah.
Yes, I've
all
done
in one line.
yes, I've done that. I mean, you can do it in 2 lines, but if 1 line is better, why not?
Yeah.
Okay, what's the next one?
Okay. So what I would do is to check if the number is greater than we can say 0. We can define another variable to check. So let's say we have a variable called check and then have it initialized to 0. And if the input is less than check, then we can say it's a negative integer. And if the input is greater than check, we can say it's a positive integer. That would be my approach.
Is this your solution?
Yeah, this exactly.
Okay, so let's run it and see. Let me clear everything from here. I like to have a clean space. Okay, and then I'll clear the screen. Okay, so I run this. It says to give it a prompt. Okay, so Okay, the input is negative. Okay, so it's working. Really simple, right? We don't have to spend so much time on this. Okay, now let's do another one. So number 2, we've done 1. It's done. Okay, thank you. Thank you for your solution, Greco. What about number 2? So this one says that we should write a program that takes the upper and lower limits and prints out all the odd numbers within it. Okay, so let me explain it. I don't know if it makes sense to you. So you take, the program is going to ask you to input a certain range, right? And so you provide the upper limit and lower limit. And then between those two ranges, we want to, print out all the odd numbers. Okay, we want to print out all the odd numbers in that range. Now, let me break it down into 2 steps. Number 1, we need to be able to find out how do we determine odd numbers, okay? And then, so that's one part of the solution. The other part is we need to be able to read in these upper and lower limits, okay? Then we have to decide what an odd number is. How do we decide that in code? So if anybody can help us, we can use parts of the first solution to go on. Any ideas?
Numbers that are not divisible by 2.
Okay, numbers that are not divisible by 2 are
Divisible
odd.
by
Right?
2. Yeah.
Okay, so at least we will use that as part of our solution. Okay, so how do we begin?
X is equals to integer input.
Okay, you all like X. Learn to use mnemonic names, nicer names. Okay, so and we do an input. Okay. And then what should be our prompt?
Odd numbers.
You mean we should say, please enter an odd number?
Yes.
Oh, then that makes it very easy. Then we have nothing to do.
Oh, please enter a number.
Okay, enter a number. All right. Yes.
Check is equals to 5.
Is equal to what?
Takes your phone. 5.
Where are you getting that number from? 5 is a magic number, huh?
If X is divisible /5. I'm /2. Sorry, /2.
So you mean check should be 2, right?
Yeah, check should be 2.
So are you going to use the check here?
Yes.
Okay.
Print.
Mm-hmm.
Input is even.
Is that what you want to say?
No, input should be even. Input is even.
Even, okay.
Else.
Oops. I suppose it's going to be the other way around. So let me help you.
Input is odd.
Okay. That's your solution. All right, let's
Yes.
see how well it works. So let me enter 1. It says 1 is even. What's wrong with our solution?
I think that maybe if we are looking for odd numbers, then we should actually be using odd numbers are numbers that are divisible, and it always has a remainder. Okay, so I mean, if that is right at all. So so what we have to do here is use the modulo operator, the modulo operator to check if, yeah, that would be my approach. So when we perform a modulo on the number, the modulo will show if the number, the remainder is greater than 0. If the remainder is greater than 0, then it means that the number is odd. But if the remainder is 0 exactly, then it means the number is even.
Okay.
Maybe we can try that approach.
Okay, great. So is it Ifeoluwa who gave the solution? Now, this here, the reason, let's find out why your code didn't work. Okay, so this one, what does it evaluate to? Does it evaluate to a Boolean? Okay, does it evaluate to a Boolean? This here. Now remember, X is a number, okay? So I put in 1, and then you divide 1 by 2. It gives you a number. Okay, so see, now let me chain together everything that, oh, sorry. Forgive me. I'm just trying to use the shortcuts, okay? So let's see what your code translated into, all right? And see whether, see, it says if, and I know it looks a bit funny, but these are some deeper aspects of Python that may be confusing in the beginning. So, but it looks like everything has a truth value as far as the programming language is concerned. So let's see the Boolean value of, I'll say 1/5. Does it have a Boolean value? It says true. Okay, so it may be a bit confusing, but Python by default also has an encoding. It has a way of, it basically has true or false values for things inside Python. Okay, so if you're not aware of that, and so outside of the regular Boolean expressions that we talked about, Python itself internally talks about things that have truth values. And this number here, a value, a number like the integer, blah, 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 they all have truth value. So if you evaluated the truth value of this expression here, even though it's a number, Python assigns a Boolean value to it, and it says it's truth. Okay, in the same way, a string, okay, like hello, has a Boolean value of true, but an empty string, okay, this is an empty string. It has a Boolean value of false. Now, these can be confusing for beginning lessons, okay, but I'm pointing it out to you. The reason why the code worked but didn't give you the answer you were looking for is that it was evaluating some Boolean value here, okay, but incorrectly according to what you were trying to do. So it's good that you understand this right away. So I'm just mentioning it to you. Later on, you can go and research a bit more about it and see. Okay, so it means that we need to do a better check. Okay, do a better check. Now, if you did this division, what do you expect? Okay, the definition for an odd number should be properly constructed so that you can do your test. Now, if you do this division, what should happen? All right, so if you did a division, say, you need to check the result of the division with a number. And typically, if you divided an even number by 2, what would be the remainder? Okay, you need to be able to find a way to check for the truth value of that expression. And one of the ways you can do it is to use the test condition. Okay, when we divide a number that is even, when we divide it by 2, what happens? Okay, so you can use that result to check and see that, oh, this number is even or not. And so as Kweku was saying, we can say, let me go ahead and say, so now let's go to your alternative solution. Okay, so can you read it out now? Let me employ it. So it says to use the modulo operator. Okay, so this is how it works. It does the division and gives us the remainder. Okay, if you didn't want to use the modulo operator, you might have to do your own version of that, but the modulo operator does that for us. Okay, it does the division and then gives us the remainder. Okay, so if you did say 3 modulo 2, what should be the answer? 1. Okay, so you can divide 3 by 2 one time, remainder 1. Okay, if you did 3 modulo, say 3, there's no remainder. Okay, if you did 3 modulo 5, it's 0 remainder 3. So that's the thing that we can use here. Okay, and you can chain it. So it's 3 modulo 5 equal to 0. Says it's not equal to 0. Okay, so you can see that this is evaluating to a Boolean expression, and that would be the thing that we want to put here. Okay, so let's combine that here and do if x modulo 2 equals 0. Okay, what next? Let's finish this solution and then we can bring our discussion to a close. Who can help me finish?
I think we can run the program now.
We can run it now. Oh, okay, we are done. Okay, so let me go again and do as I did. This time it says it's odd. Let me enter 2. It says it's even. Let me run it again. Sorry. Enter 3 is odd. Okay, so it looks like we are getting the solution we want. Great. All right, so I'm going to leave it here at this point. Let me see if anybody has a question or contribution. Then we can end the session.
Okay, so I'm looking at the comment on line 27. Says the program takes the upper and lower limit and prints all odd numbers. So in that situation, were we expecting the user to give a lower limit, like to give 2 inputs, take the first input maybe as a lower limit and the second input as the upper limit and print the numbers in between? How about that?
Great. So actually, we haven't finished our solution. Okay, so this is one, a small part of the solution. So here we need to, since we said we are getting the input from the user, okay, we need to manually 1 by 1 take the input from the user. So what we're going to do here is, let's say we need to take the lower limit. Just to make it meaningful, I'm just going to say, please enter the lower limit, okay? As if we already know what we are doing. Later, if you wanted to make this a full-blown program, you can structure it more and print some message before you actually do this. Okay, so we can do the upper limit here. Is this how we write upper? Okay. Okay, so from here, what do we do? Now we need to be able to generate numbers between these two limits. Okay, so let me give you another gift of a function that Python gives us for free. So there is this function, it's called range, okay, built into Python. And it allows you to generate a number or a sequence between a start and then a stopping point. Okay, so based on these two limits, we can generate the sequence, right? Okay, because it takes the upper and lower limit and prints all the odd numbers. So we're going to have a sequence of numbers, and then we can use this logic here to print out all the odd numbers. Okay, so with that, let's say that these are the numbers. Okay, so we use the lower limit. We use the lower limits. All right. And then we use the upper. I did some wrong indentation here. So this should work for us. How do we proceed from this point? We haven't really tackled loops yet, but I'm gonna bring it in anyways, okay? Because we need to find a way to address each one of the numbers in this. So let me show you what is gonna happen here when we do this. Okay, so the lower limit, let's say the lower limit is 1, okay? The upper limit is, let's just make it 10. Okay, so if you inspect the numbers here, it has created this range for us. And actually, properly, I could still loop over this, but I want to show you exactly what this looks like. Okay, so let me wrap it around a list data structure, which I would go into later. Okay, so if you look at the variable explorer here, let me show you. You can see that the numbers here is a list of numbers, right? Our lower limit here is 1. Our upper limit here is 10. And so this is the list. Can you see? Our job now is to go through them one by one and then apply this test to it. Okay. So should we do that? Okay. And this is where we introduce the new keyword, okay, for each number, okay, in the numbers list. What we want you to do is for you to apply this test, okay, to the number. And then give us this output. And that's all. So I told you that once you're able to figure out this part, we have added, the only thing that I've added now is just this portion, okay, to your solution. So you can see that this variable here, we don't really need it. And let's go ahead and see how this behaves. Okay, so you can see, does it make sense? So just so that it's also, it's more meaningful. Let me just do one more thing. Okay, so I'm gonna just let me do one more thing. Okay, so let me just run this again, this portion of the code. And you can see now the numbers that are being printed out as odd and even, right? 2 is even, 3 is odd, 4 is even, 5 is odd, like that. Does it make sense? Does it make sense? Oh, no one is talking to me.
Yeah, it makes sense. I got disconnected for a while. I think I have similar solution here. It totally makes sense.
Okay, what's your solution like? Maybe you didn't use the range function, but what does it look like?
Okay, so I was wondering what process I was going to get the lower and upper limit. So immediately you introduce the range limit. I use the range limit, but I don't have it wrapped around in list. So I have the variable assigned with the value of range, and then I have the lower limit being the first input, and then the upper limit being the second input, and then I run a loop through the variable that I have assigned with the range function. And so in my loop, I have another conditional checking if the number is divisible by 2, or if the number is even or odd, and if it's even, it gets printed, and if it's odd, sorry, I'm only printing odd numbers, so that's what I'm only checking for and printing to the screen. Yeah.
A better job than what we did together. All right, so since we are interested in only the odd numbers, we should mute this portion, right, and do nothing. Okay, let me just, we don't want to do anything when it's mute. I mean, we just want so you skipped, right? And then you can even have a shorter solution, right? And okay, right, something like this.
Yeah.
Yep, good. And so if, again, your solution would show us how well you've thought about the problem. Okay, so it's actually a very short program. Maybe it could be even shorter than this, but these are the key components of this problem, and that's it. So what we have done is we've applied some decision making. We've applied, creating variables, but this time reading variables, your data from the standard input, your keyboard, and then doing your proper type conversion. We've introduced a new function here, which is a built-in function. I didn't talk about that, but if you wanted to learn more about the built-in functions, I told you this function here is really helpful. You could search for this keyword here, built-ins, that would show you a whole lot of things that come built into Python. Okay, these are all things that are there, built already into Python, and some of the functions that we've used, max, int, and all these functions. Len is a function that is built into Python. think the one that we just used, range, should be somewhere there. Good. Yep, it's here. Okay, so it's part of the standard library. Okay, so exactly, I'm just gonna leave it here for today. Okay, we've done a couple of things, and we've introduced iterations. So in our subsequent interactions, we're going to spend more time on this portion, and then we're going to do a lot more practice exercises, because it is only if you're able to solve problems that you know that you know. All right, otherwise I could give you long lectures, but it won't really translate into practical knowledge. So folks, at this point, I'm going to leave it here. If there are any questions or comments, I'm going to answer them, but otherwise I want to bring the session to an end, and thank you all for making it. All right, then. Looks like there's no question. So folks, thank you so much for making time for today as well. We will continue the series, and later on in the group too, if you have any question, you can just ask me and I'll provide you feedback. So enjoy the rest of your week. See you later.
All right. You too.
All right.
Thanks.